Hi everyone, this is my final assignment of KKMM 1413 Introduction to Electric and Electronic. This is my final assignment. Uh, Let us start our presentation for this assignment. First, we look at the question 1. An unknown circuit with an input voltage supply give an output voltage shown in the figure 2. And this is input voltage and an unknown circuit and the output voltage. And from the figure 2, we know the input maximum amplitude of the input voltage is phi, and the time t is 125 millisecond, and the maximum amplitude of the output voltage is 3. For the 1A question, we need to use the resistor and capacitor to build a circuit to show this graph. Okay. First, I built a circuit with the capacitor and resistor, which is a high-pass filter. We also can call it a high-pass filter. And we know the formula for the omega frequency is 2 pi f, or equal to 2 pi over t. And we substitute t into this formula, and we can get the omega frequency equal to 16 pi radians per second. Now we need to find the phase difference for the output voltage. We use this formula y equal to a cos wt plus phase difference, and we substitute y equal to 1 when t equal to 0, and we can get the phase difference equal to 1.231 radius. Now we need to find the value of the capacitance and the resistor. We use the voltage divider rule. The output voltage equal to R divided by the total voltage, which is 1 over J WC plus R multiplied V input, and then we will get the gain voltage equal to this. Then we let capacitor equal to 0.1 microfarad, and this output voltage and the input voltage is from the graph, and we substitute the this value into this equation. We can get the resistor equal to 149.2 kilo ohms. And then we look at the LT spice. Okay, this is the circuit I built up in the LP spice. This is the sine AC voltage. The amplitude is phi, and the frequency is 8, which we calculate with the F equal to 1 over T. And here is the input voltage, and here is the output voltage. This is the transist. Time stop I set at the 281.25 milli, and time to start saving the data is 31.25 milli, and the maximum time step is 0.1 milli. The time to start saving the data is 31.25 milli. Is because I want to show the graph is the cost graph, which is same with the question given. And then we run the circuit. This is the input, and start from voltage 5, and this is the output. The time t also is equal to 125 millisecond. We can get the same graph in the same graph with the figure 2, and that means our calculation is true and our circuit is true. Next, we go to the question 2. An unknown passive filter gives a frequency response of gain and phase shift show in figure 3 the value of FL, FC, and FH is 1 kHz, 5 kHz, and 10 kHz respectively. From this graph, from this graph, we know this is the band stop filter, and FL is low cut-off frequency, and FC is Norton frequency, and FH is high cut-off frequency. For the 1A question, we need to use a resistor and inductor to build a circuit. And then we look at the circuit I built. We know that the band stop filter is the also can find out with the combination of high pass filter and low pass filter. For this part, first part is the high pass filter, which the resistor and the inductor is parallel, and the second part, which the resistor and the inductor is series, is a low pass filter. For the for the formula of the cutoff frequency, we know that F cutoff equal to R over 2 pi L. After that, we need to find the value of resistor and the inductor. For the first part, which the high pass filter, the high cutoff frequency is equal to 10 kHz, and we substitute into this formula, and we can get the R1 equal to 6.3 kilo ohms. And for the second part, the low pass filter, uh, low cut-off frequency equal to 1 kHz, and we substitute into this formula, we can get the R2 equal to 630 ohms. Next, we look at the LT spice. This is the circuit I built in the LT spice. This is the sound I built AC mount amplitude with 1, and here is output, and the value of the resistor and the inductor is same with the calculation I calculate. This we choose the AC analysis. The type suite is decay, and the number of point per decay is 100K. Start frequency is 10, and the stop frequency is 1000K. Then we run the circuit, and the output voltage will show a band stop filter. The cutoff frequency will approximate to 1 kHz and 10 kHz, and this is the phase which he will drop and up again and drop again. Also, same with the question given, like this. So this is all for me for the explanation, my theoretical calculation, and how I build the LT Spice simulation. Thank you.